My name is Ruth Lezama from Universidad Juárez Autónoma de Tabasco. Today, I am presenting our work entitled Evaluation of the Antioxidant and Antimicrobial Activities of the Extracts Obtained from the Leaves and Bark of Wazuma ulmifolia. Wazuma ulmifolia, commonly known as mutamba or guasimo, is an arboreal species found in Latin American countries and is native to this region. Hydroethanolic extracts from its leaves have shown several biological activities, notably antimicrobial, antioxidant, antiprotozoal, and cardioprotective effects. However, there are still limited scientific reports that confirm its biological properties. For this reason, we aim to evaluate the antioxidant and antimicrobial activities of hexane, ethyl acetate, methanolic, aranolic, and aqueous extracts from the leaves and bark of Wazuma ulmifolia. To carry out this study, we obtained extracts using solvents of different polarities. The antioxidant activity was evaluated through the ABTS radical scavening assay, while total phenolic and flavonoid contents were determined spectrophotometrically. For antimicrobial activity, we test the extracts against Staphylococcus aureus by measuring inhibition zones and MIC values. As you can see in Table 1, yields from leaves range between 0.7 and 2%, while those from stem bark range from 1.1 to 16%. The leaf yields are consistent with the ethyl acetate extract of Wazuma ulmifolia reported by Guinarno, which obtained 1.58%. In the present study, the differences in yields suggest that the type of solvent and the characteristics of the sample influence the quantity of extract obtained. Antioxidant activity was evaluated as the percentage of radical inhibition, ABTS, as shown in Figure 3. The highest percentages were observed from stem bark, methanol, ethanol, and aqueous extracts, although the methanol extract was 6.6 units lower than the ascorbic acid standard. It is also important to note that the IC15 value of the methanol extract was comparable to that of the ascorbic acid standard. In a study published of G. ulmifolia flavonoids obtained from leaf aqueous extracts showed higher antioxidant activity than alpha tocopherol at 200 ppm concentration. The chemical profile of Wazuma ulmifolia extracts was determined on the infrared spectrum shown in Figure 8. It must be highlighted that the bands corresponding to different functional groups, such as alcohols, alkanes, and alkenes vibrations. As observed in Figure 7, in contrast to our findings, Dos Santos reported higher phenolic content in aqueous extracts in both stem bark and leaves. In this study, in most cases, the phenolic and flavonoid contents were higher in the stem bark compared to the leaves. Based on these findings, we next examine the antibacterial activity against Staphylococcus aureus. The results indicate all leaf extracts were negative using the disc diffusion method. Positive results were observed for stem bark extracts, specifically methanol, ethanol, and aqueous extracts. The lowest MIC values were found for the ethanol and methanol stem bark extracts. The MIC values reported here were lower compared to previous work on G. by Violanti, in which the ethanolic extract and ethyl acetate fraction showed the highest activity against Staphylococcus aureus with MIC values ranging from 62.5 to greater than 1,000 micrograms per milliliters. We conclude that methanolic, ethanolic, and aqueous stem bark extracts of Wasuma ulmifolia exhibited the highest antioxidant antimicrobial activities against Staphylococcus aureus. These findings correlate with the higher polyphenol and flavonoid contents, suggesting that these compounds may be linked to the observed biological properties. Overall, the results indicate that Wasuma ulmifolia is a potential source of bioactive compounds with applications in pharmacology or nanomaterial synthesis. Further studies are recommended to isolate the responsible compounds and assess their efficacy in biological models.